Alright, so in so in today's video we will be uh, discussing the conversions for O-level computer science, binary to hex, and all of that, and the decimal, denary, all of that. So alright, so you have three different number systems. You have denary or decimal. You have binary, and you have hexadecimal. So denary is 0 to 9, binary is 0 and 1, and hexadecimal is 0 to 9 and A to F. So first let's start with binary to hexadecimal. Binary to, not hexadecimal, denary. So binary to denary. Let's say you have a number 0, 0, 1, 1, 0, 0, 1, 1. So basically, you would write it like this. You would write it 1, 2, 8, 64, 32, 16, 8, 4, 2, 1. And now we would simply rewrite this again. 1, 1, 0, 0, 1, 1. So why do we do this? This is because the binary system is based on the number 2. So it can only be 0 and 1. So basically, this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, and so on, to the power 6, to the power 7. Which is why we write the binary number here, and then we basically solve it. So if all of these were, let's say, 1, you would add 128 plus 64 plus 32 plus 16 plus 8. But only 32, 16, 2, and 1 are 1. So 32 plus 16 plus 2 plus 1 is going to be 51. So that's how you solve binary to denary. Another quick example: 1, 1, 1, 0, triple 1, 0. Again, 128, 64, 32. Let me quickly write that. 128, 64, 32, 16, 8, 4, 2, 1. 1, 1, 1, 0, triple 1, and then 0. So 128, 128 plus 64 plus 32 plus 8 plus 4 plus 2, and then 1 is 0, so this would be a total of 128, 432, 8, 4, 2, 238. So that's how you convert from binary to denary. Now, what if you have to do the opposite, denary to binary? Denary to binary. Let's say you're given the number 107. You have two methods of solving this. Either you solve it kind of like the way you do binary to denary. You write down these numbers, 16, 8, 4, 2, 1. But instead of having the numbers, you figure it out yourself. Like 120 is greater than 107, so no. 64, yeah. 32, 64 plus 32 is 96, so yeah, it could be. 16, no, because that would be greater than 107, so 0. 96 plus 8 is 104, so 1. And then 104 plus 4 would be 108, so 0. And then 1, 1, because 104 plus 2 is 6, 106, and then you add 107. So your answer would be 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1. That's one way of solving it. Let's say m1. m2 would be like continuously divided by 2. So let's make a small diagram. Let's call this r, remainder, and we just keep dividing by 2. So our 7 divided by 2, 53 with a remainder of 1. You don't have to write remainder, but this is just to explain it better. 2 again, will be 26 with a remainder of 1. Divided by 2, 13, remainder 0. Divided by 2, you would get 6 with a remainder of 1. Divided by 2 again, you get 3. Go down again. That would give you a remainder of 0. Divided by 2, you would get 1 with a remainder of 1. And then divide that by 2 again. And you would get 0, 1. So then you read it from the bottom to the top, like that. So our answer would be 1, 1, 1, 1. Oh wait, no, you don't read this. Sorry, you just directly go from above. You do read it, but we have 8 digits already, so, and a 0, it would be unnecessary. So 1, 1, 0, 1, 0, 1. Never mind. There you go. And then 0, 1, 1, 0, 1, and 0, double 1. Does this compare to this? It does. Perfect. So that's how you convert denary to binary from both methods. Now let's move on to binary to hexadecimal. Binary to hex. I will be referring to hexadecimal as hex because it is shorter and it conveys the same thing. So let's say you have a number 1011 and then 1110 0001. So this is 12 digits in total. If you want to convert it, you would divide into 4. And a question, it's not normally going to be divided like this. It's just to make it easier. So first, let's start from here. You're gonna use 8, 4, 2, 1, 8, 4, 2, 1, 8, 4, 2, 1. So 8 plus 2 plus 1, 8 plus 2 plus 1 is going to be equal to 11 because and then 11 in hexadecimal is B. So why is it B? Let's come back to the top. In hexadecimal you have 0 to 9 and then A to F. So 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. So this is B. This is going to be 8 plus 4 plus 2, which is 14. 14 is referred to as E. And then over here, it's just 1, so 1. So your answer is B, E, 1. Another example is, let's write a number like this. 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 0, 1. So first we're going to divide into 4. So 1 here, 1 here, 1 here, and what do we do now because there are 4 digits? Well, you can just simply add 2 zeros and to make it perfect. So 0, 0, 1, 0, 0, 0, 0, 1, 1, 1, 1, 1, and 1101. So 8421, 8421, 8421, and then 8421. So in here it's just 2. So 2, 1. This is going to be 15 because a plus 4, 12, 14, 15. So F. And then a plus 4 is 12, 12 plus 1 is 13, 13 is going to be D. So the answer is 2121FD. And yeah, that's how you solve it. Now, let's say we are going to now do vice versa, so hex to binary. Let's say you're given the digits 4 or 5 from the alphabet A. This is also kind of straightforward. You can basically figure it out yourselves in binary. So 8, 4, 2, 1. You would write 1 here, and for 4, for 5, you would do 8, 4, 2, 1 again. 0, 1, 0, 1, because 4 plus 1 is 5. And then for A is 10. So 8, 4, 2, 1. You would write 1, 0, 1, 0, because a plus 2 is 10 and a is 10. So your answer would be 0, 1, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0. You don't have to leave all this space. I'm just doing it to explain this is this, this is this, and then this is this. Combine them in order. Let's do another example. BF08. So B is 11. So 8421, 8421, 8421, and 8421. B is 11. So 1, 0, 1, 1, because a plus 2 is 10. 10 plus 1 is 11. F is 15. So 1, 1, 1, 1. 0, so 0, 0, 0, 0, and 8, so 1, 0, 0, 0. So answer to this would be 1, 0, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, and 1, 0, 0, 0. Now, finally, we have denary to hexadecimal and hexadecimal to denary. Denary to hex. Let's leave it like that. Let's say you have a number. Let's use 45A again. This is denary to hex. Oh wait, no. Let's this is hexadecimal. There we go. So since we're using hexadecimal, we're gonna do the same thing that we had initially, but instead of 1, 2, 4, 8, 16, it's hexadecimal, so 16 to 56. So in the hexadecimal system, it's base 16, so you go up 16 times. That's why, if that didn't make sense. Anyway, you're gonna do 4 into 256 brackets plus. Let me actually just run this off. There we go. You just basically multiply this by 256. I think after this, let's say there's another number here, you would multiply that by 4096. And then you would do 5 into 16. 5 to 16, and then a is 10, so plus 10 into 1. This would be equal to 1024 plus 80 plus 10, which is going to give us 1114. Let's do another example. C, 8, and F. C will be multiplied by 256. C is 12, so 12 into 256. and then add that by 8 into 16, 8 into 16, plus f, which is 15, 15 into 1. 12 to 56, 3072, plus 8 into 16, I believe that is 128. Let me double check. It is 128, and then plus 15. So altogether, when you add this, it will be 3,215. Finally, we have denary to hexadecimal. Oh wait, I forgot to mention, if this is too hard, you can also use, you can basically convert hexadecimal to binary, and then from binary to denary. So let's also write that down right here. Hexadecimal to binary, and then binary to denary. Let's just go on to the next question. Next and final conversion, denary to hexadecimal. So for this, you can also do denary to binary and then binary to hexadecimal, but let's not get into that right now. So denary to hexadecimal, you have two methods. Method 1, let's say you have 2004. Method 1 is kind of hard because you have to multiply. So let's say it's base 16, right? So you have 256, 16, and 1. You don't really know what digits to multiply with, so but I have it with me. So 7 into 256 plus 13 into 16 plus 4 into 1, which gives me 2004. So you would read this as 7 is 7, and then 13 is D, 4 is 4. So that would be your answer. But this method is a bit hard because you don't really know what to multiply with. So instead, method 2, 2004, and then you divide this by 16. Kind of like what we did with binary, except you divide it by 16. So 2004 divided by 16 is 125 with a remainder of 4, and then divided by 16 again, you have 7 with a remainder of 13, divided by 16 again, you get 0 with a remainder of 7. So answer is going to be 7, D, 4. And yeah, those are all the conversions that you have in O-level computer science. That's the end of this video, and yeah, peace.